This presentation is going to be about how salt from melting ice on roads can cause pollution. Why do we use salt to melt ice on roads, and who is it benefiting? Salt, or NaCl, is used on roads, highways, and sidewalks in areas where there is heavy snowfall and ice. The salt relieves the amount of snow and ice getting packed down on roads and pavement, making it easier to keep clear. It is commonly used in areas with heavy snowfall and long, cold winters. Using salt to melt the ice on the roads benefits people who live in areas with heavy snow. It makes the road conditions safer and more manageable, and it also makes it easier to shovel heavy snow on sidewalks and driveways. What institutions are hurting and what institutions are helping this issue? The Environmental Protection Agency is the main institution hurting the issue. They advocate about how the salt is harmful to the environment. Other environmental organizations are also advocating against the amount of salt used to clear roads. The State Department of Transportation is the main institution helping the issue. They're the ones who send the plows out to clear the roads with salt. However, they are starting to implement smart salting to minimize the amount of salt used on the roads. What effects are we experiencing now, and what effects could we experience down the road? By using salt to melt ice on the roads, it can cause many different environmental issues by getting into streams, lakes, and rivers. This happens when salt is funneled into storm drains that empty into these bodies of water. This causes our fresh water to become saltier and saltier each year. Salt can also get into the soil, affecting the soil structure and potentially harming plant growth. Salt can also cause corrosion on vehicles, bridges, and roads. If we keep using a large amount of salt each year to melt ice, we can expect to see an increase of pollution in the water, which will affect the organisms living in it, along with damage to roadside vegetation. We can also expect to have to do more repairs on infrastructure due to the salt. Alternatives. Sand. Sand adds traction and it also absorbs sunlight, which can help melt snow and ice. However, sand cannot melt ice as effectively as salt would. Calcium chloride. Calcium chloride is an inorganic formula that is actually more effective than regular road salt. It is less harsh and it actually works better with lower temperatures. Calcium magnesium acetate. Calcium magnesium acetate is effective against ice formation with its small granules covering larger areas with less amount needing to be used. Alfalfa meal. Alfalfa meal is an all-natural fertilizer that provides traction, and the nitrogen in it also acts as a de-icer. It's longer lasting than regular road salt, so you don't need to use as much of it. Beet juice. Beet juice is one of the most environmentally friendly ways to melt the ice. It lowers the freezing point of ice, and it helps de-icers stick to the ground better. And lastly, coffee grounds. Coffee grounds contain nitrogen, which works to lower the melting point of ice, and the dark color absorbs the sunlight better than salt. Pros and cons. Pros. Salt effectively melts the ice on the roads. It reduces accidents by up to 85%. It's easier to plow and shovel. It helps prevent snow and ice getting packed down, and it just makes all-around safer road conditions. Cons. Salt contaminates drinking water, it increases soil erosion, it can kill and endanger wildlife, it causes vehicles to rust, and it's damaging to infrastructure. What courses of action is there to pursue? Limiting the amount of salt on the roads and using alternative methods like sand, calcium chloride, calcium magnesium acetate, and etc. would be the most effective way to have a more positive impact on the environment. Another idea is to improve the drainage system so that it filters out the harmful chemicals getting released into our environment. Science concepts. So the first science concept I'm going to talk about is a chemical reaction and how salt melting ice is a chemical reaction. So when the salt dissolves into the water, it breaks apart into sodium and chloride ions, which as a result disrupts the ice crystal structure. This disruption of the ice crystal structure lowers the freezing point of the water, allowing the ice to melt at a temperature below its normal melting point. And then this picture just shows how the salt kind of separates everything and causes it to melt. And then the next concept I have is a redox reaction and how salt causes corrosion on infrastructure. So the chloride ions in salt cause corrosion on infrastructure by acting as an electrolyte, which speeds up the rusting process on metal by disrupting the protective oxide layer. When the salt dissolves in water, it creates a conductive solution where the sodium and chloride ions facilitate the transfer of electrons, causing the corrosion reactions on metal. The chloride ions can also easily penetrate concrete and reach reinforcing steel within, which breaks down the protective passive layer on the metal, causing the rusting to happen. And then this picture is just an example of how the salt can cause corrosion, and it's an example of a redox reaction.